Okay, today's lesson is on surface areas of two specific shapes, cylinders and cones. So we've done surface area before. Surface area is, well, I should just first of all say area. We know that for area, it might be when you're finding like a flat surface, you'd be finding the area, the space, the shape takes up, like in units would be meters squared or inches squared. So you typically have like rectangles, and you would find the area is like how many little square units are in this rectangle, how many little spaces it takes up. But by saying surface area, what it's actually referring to is some 3D shapes, and we need to find the area of all the outside or exposed area of those shapes. So the shapes we'll be looking at is a cylinder and a cone. And so a cylinder, if you think about a cylinder, we can think about it like, like a can of Coke or something like that. And we'd want to find all the outside faces and find the areas of each of those faces and add them together. Now the areas of the faces are all technically can be laid flat. If we like unpeeled things and pulled it apart, you could eventually lay it flat. Like think about if you had like a box, like a cardboard box, and it's a 3D box, but then you cut it up, you could lay it flat. If you could lay something flat, that's called, and draw it, that's called the net drawing of like what it would be flat. So if we can think about it that way, it might help you visualize what's going on. Let me show you first like a cylinder here. I don't have a way to cover the top and the bottom of this cylinder, but you can get the idea that this is a cylinder and it's round. But as round as it is, if I was to lay it flat, it would be called a net. You can see that what it is flat, unrolled, is just a rectangle, or maybe in this case it's a square, but that's unusual. But it's some kind of rectangle here. So we would technically, the picture of what this would look like unfolded would be, if I peeled this off, we would have some kind of rectangle right here. And then we would have a circle on top and a circle on bottom. So you can just put a circle on top and on bottom. And that's like what this cylinder would be completely flattened out. So we just need to find the areas of two circles and this rectangle. So the two circles that have a radius, they would be the same radius for the top and the bottom. So the surface area here, we'll start by finding the area of a circle, which is pi r squared. But there's two circles, so I'll multiply that by 2. So this is just saying 2 circles. And then those are the bases. The bases there. Now this shape here is just a rectangle, so I'm going to have to add some other piece here, and that's just the rectangle. What that rectangle is called is the lateral area. The area going from base to base, this is called the lateral area. So how would we find this here? Well, we would need the height of this cylinder. So the height needs there. And then we need to know the base. But the base it's not flat to begin with. Like it originally was rounded like this. But watch what happens as I look at the base here of this round, it's like wrapped around here. If I unfold it, it becomes a straight line. So this becomes the base, but at one point it's a cylinder. So the base, excuse me, the base is the length around the circle. The length around the circle is how long this piece is going to be. So this line of the base is the length around the circle. So how do you find the length going around a circle? The length around a circle has a name. It is the circumference. So the circumference, we know hopefully how to find the circumference. The formula for circumference is 2 pi r. So in our formula, we know, or in our picture here, that this baseline at the bottom is the circumference line around the circle. Then to find the area of this as a rectangle, you would do base times height. So 2 pi r 8 times h. And there's our formula for the volume, or the surface area of the cylinder. Let's take a look at the cone. The cone is, when it's unwrapped, if you can unwrap it, you'd have a circle at the bottom. So laid flat would have a circle here, and then it creates like a shape like this to make the cone. It's kind of like a coffee filter almost, where like if you could wrap something, I don't know if I can do a good job of it, but you can kind of make a cone out of this, pretty sloppy one, but kind of make a cone out of this flat paper. It's not perfect though, whatever. So with this, you need to find the surface area would be to find the area of these two shapes added together. So the surface area equals, the first shape I'm going to use is the circle here, and the circle has some radius. The area of one circle is pi r squared, and we only have one circle. So this is the circle, and that's the base, plus, and then this is called the lateral area going around the sides. Lateral area. And it's kind of a funky shape. It's not a triangle. It's not a perfect triangle there. So it's not like 1/2 base times height. It has a little bit of a special formula here. It is pi r for radius, and then L is a new vocab word here. L is the length of this slanted height. So L is called the slant height. So there's a regular height that always, a regular height goes up and down at a 90-degree angle. That would be h. Notice that h is not in the formula. We don't use this height. We use the slanted height in this case to find that lateral area here. So pi RL, make sure we know it. We're looking for that height in our formula. Well, I'll put that into our notes here. If you haven't already written this down, this is basically the same idea as going into the notes. So let's review what we've got here. So for cylinders, the surface area is 2 circles. So 2 circles plus 1 rectangle, and the rectangle has a base that is the circumference times height, 2 pi r h. So plus the rectangle, and again, that's the lateral area. On the cone, we have the surface area is the circle, pi r squared, so that's the circle base, plus the lateral area, which is pi r l. And we use a cursive L typically for that. So, and this is lateral area. And make sure we label here that L, or it doesn't matter which side, L is the slant height. And that's what we need. This is the regular height, or the altitude, but we need the slant height. Okay, let's go ahead and try some of these examples, and then you can check with my answers if you need any help.